Hey everyone, this is Math Done Right, and today we're going to be looking at the quadratic formula and the discriminant, and this is going to be part one of a three-part series, and this one is keeping it real. And so let's remember again, a quadratic equation is some equation of the form ax squared plus bx plus c equals 0, and that's where a does not equal 0. And for quadratic equations, I have three different types of solutions. There's two real distinct solutions, one real solution, and two imaginary solutions. And when I say distinct here, that basically means different. So I can have like x equals 2 and x equals 3. And in this video, we're going to be looking at the case where I have two real distinct solutions for my quadratic equation. Now, what exactly does it mean for a quadratic equation to have two real distinct solutions? What does that mean? So I have two real distinct solutions. So that means I should have two real numbers that when I plug into my equation, I get a 0 out. So I have two real numbers that I plug into my equation and get a 0 out. So that means if I were to graph this equation, it should cross the x-axis twice. So an example of a quadratic equation as a graph should look like this, and where it crosses the x-axis are my two solutions right here. This would be my first solution, and this is my second solution. So I'm kind of trying to tie everything together, right? You know, there's a little bit of algebra, a little bit of graphing, and this is the graphical interpretation of the discriminant. If that b squared minus 4ac is greater than 0, it's going to give us a quadratic that looks like this. So if we look at the quadratic equation ax squared plus bx plus c equal to 0, the discriminant is b squared minus 4ac. And that's true for any quadratic equation. The discriminant is always this, right? And depending on what your a, b, and c values are, this is going to change. Now, in this video, we're looking at a quadratic equation with two real solutions. So two real solutions. And that happens when b squared minus 4ac is greater than 0. All right, this is the key here. If I take my a, b, and c value and plug it into this little equation right here, if it's positive, that means I have two real solutions. And the quadratic equation, the quadratic formula, is x equals minus b plus or minus the square root of b squared minus 4ac all divided by 2a. Now, right, there's probably videos somewhere on YouTube of people singing this to the tune of Pop Goes the Weasel, but that's not really my thing. So there's the quadratic formula, and the thing to notice here is notice that underneath the square root, let me use a different color because I like using different colors. Underneath the square root sign, I have this b squared minus 4ac in here, right? And so the discriminant and the quadratic formula are super related to each other. In fact, the discriminant is inside of the quadratic formula. And so when I'm doing examples, if I calculate this first, well then I can just take what I calculate and shove it in there. And that's actually exactly what I'm going to do for this next example right here. Alright, so now we're going to look at an example and determine what kind of solutions this equation has. So we're going to look at 3x squared minus 3x minus 6 equal to 0. So I want to identify my a, my b, and my c. Well, in this equation, I have a is 3, b is negative 3, and c is negative 6. So now I write down what the discriminant is. It's b squared minus 4ac. So in this case, it's equal to minus 3 squared. And remember, it's super important that I have the minus 3 squared to get rid of that minus sign eventually when I square it. Then minus 4 times 3 times minus 6. Now when I square negative 3, I get 9. I'm going to have this minus and this minus here give me a plus. I have 4 times 3 is 12. 12 times 6 gives me 72, which is 81, which is greater than 0. So this has two real solutions. Because the discriminant was positive, that tells me that my equation has two real solutions. Now we're going to look at the same equation and find what those solutions are. So we're going to find what x values, when I plug back into this equation, give me 0. And to do that, I'm going to use the quadratic formula. Remember, that's x equals minus b plus or minus the square root of b squared minus 4ac, all divided by 2a. And let's write down that a is 3, b is minus 3, and c is negative 6. So using these values, I go back and I try to solve for x. So I have minus 3 gives me a plus 3. Then I have plus or minus the square root of b squared minus 4ac. Well, I just figured that out in the last slide I just did, and that gives me 81. Right? This is the discriminant underneath here, and I just found out that it was 81, which is greater than 0, so that's giving me two real solutions. So I don't need to do this calculation again. And then I divide everything by 2 times a, which is 6. So that's going to give me equal to 3 plus or minus 9, right? The square root of 81 is 9 over 6. So that gives me that x is equal to 3 plus 9 over 6, and x equals 3 minus 9 over 6, right? I get the 3 plus 9, 3 minus 9. So that gives me 12 over 6, which is 2, and this gives me negative 6 over 6, which is negative 1. And these are my two solutions, x equals 2 and x equals negative 1. And I can check to see if I plug in a 2 here, I'd get 0. If I plug in a negative 1 here, I would get 0 also. Okay, well that is that's the gist of the quadratic equation and the discriminant for two real solutions. Make sure you check out parts 2 and 3 for one real solution and imaginary solutions. Make sure to subscribe and like it, share with your friends. Thanks for watching. Bye.